All right, so here's what I'd like you to go and do. Yeah, you can get the app.
What's this app called?
Decimals, but we'll talk about that in a second. So I'm going to go over any problems you have on the homework. I'm going to start with 37. Were there questions on number 37?
Yeah.
Yes, okay. So we'll start at 37. So I'm not going to wait on the camera. All right. 37 says, the junior-senior prom committee must consist of 5 to 8 representatives from the junior and senior classes. The committee must include at least 2 juniors and at least 2 seniors. X be the number of juniors and Y be the number of seniors. Can everybody see? Yep. Okay. So the part A asks you to write all the inequalities. We can just say, it already tells you, X is juniors. So X is juniors. And Y, seniors. The committee must include at least 2 juniors. Means you can have more than 2 juniors, but at least 2. So since juniors are X, and I want to have at least 2, this would be more than 2. This would be at least 2. So at least 2 juniors. Same thing with seniors, at least 2 seniors. If at any point in time I'm doing an inequality, and you have no idea how I got it, just stop me and I'll re-explain. Okay, so I need at least 2 juniors, at least 2 seniors. There's another part right there in the beginning that says the junior-senior prom committee must consist of 5 to 8 representatives from the junior and senior classes. Meaning that all my juniors and all my seniors, there have to be at least 5 of them. So X plus Y has to be greater than or equal to 5. To 8. Again, all my juniors and all my seniors have to be less than or equal to 8. So there have to be at least 5 of them, but no more than 8. Do those inequalities make sense? So those are all the inequalities you need for the problem. However, we want to get these into just one variable on one side. So I'll just rewrite these because we're going to be using the computer in a second. So I've got X greater than or equal to 2, Y greater than or equal to 2. If I change the first one, I would have Y greater than or equal to negative X plus 5, and Y less than or equal to negative X plus 8. So 37 part A, right there. Now, done with inspires. I hate inspires. I hate wasting my life, so done with inspires for now. So are you. Sorry, I really hate inspires. No, I'm just messing with you guys. It's just a lot easier if you do the Desmos other than the Inspire. So here's what we're going to do. You're going to open your browser. Do you remember the complicated directions I gave the other day? Okay, watch how easy this will be. So you go to Google, go to Desmos, graphing calculator. And let's say we want to graph. So our first one was X is greater than or equal to 2. So we can click on X. You go down here, there's a little tab. If it's not up, you just click on this keyboard. It says enter keyboard. Go in the tab. We want X to be greater than or equal to 2. Bam. Press the down arrow. We want Y to be greater than or equal to 2. So Y greater than or equal to 2. Bam. We want the next one. Y is greater than or equal to negative X plus 5. So Y is greater than or equal to negative X plus 5. There we go. So as of right now, if you're looking, this was the first feasible region. Then this went that way, so that means we had that little rectangle that was the feasible region. Now we have this green line that cuts the feasible region from here to here to here to here to here to here. So a little pentagon. And the last one. Y is less than or equal to negative X plus 8. So that does a bunch more shading. But since this one went that way, our feasible region will be zoom out in a second. Actually, let's zoom out now.
Do you want to draw this on a
No. Let's zoom out just a little bit. So we've got 1 point right here,
So 14.
1 point right here, 1 point right here, and 1 point right here. Instead of doing a trace and trying to calculate all that out, you're going to take your little mouse pad or your finger and just click on it. Oh, 2, 3. So we're going to write that down as one of our solutions. When you're doing linear programming, that's what you'd be doing. So 2, 3 is one of them. 3, 2 is another one.
There is nice solutions as you know.
Pardon?
Two, just two. Right?
Yeah, just 2. I'm just going to show you all 4 because it's so much easier. 2, 6.
Can you pick a point right in the middle there?
You can. 2, 6. And 6, 2. These are just when we're doing linear programming, Ben, that will give us the best possible solution. One of them will give us the most profit. But these are just setting up inequality. Yes, you could pick this point, or this point, or this point, or this point, or this point, any one of these points and set the feasible region, which was right here. A lot quicker than yesterday, right? So now we have more time to do things with our lives. That's it for 37. You can just give me any one of those points. Yes?
I'm still pretty confused on how you have the solutions.
Oh, you had solutions? So, do you remember when we were graphing? The first inequality went straight up.
Yeah.
Okay. Second inequality went straight to the right. So our new feasible region was this rectangle right here. Okay. And then our green line went up like this, which cut out this little tiny piece of the rectangle. And then the blue line went from here down that way, which cut out all of this green. So my solution area is this trapezoid. Would you agree with that? So the most optimal points would be any one of the corners. Any one of the corners of your feasible regions. Here, 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 here. And if you're trying to find them, just click on them.
Yeah.
Yes, sir.
But that's only if the lines are greater than or else they're equal to, right? If it's not, then it wouldn't work.
Right. Exactly.
Also, couldn't solution just be anywhere inside the feasible region?
Yes. This is going to be anywhere inside the feasible region, but when we're doing linear programming, you want the one that's going to give you the most amount of profit. And the corner principle tells you that the one that will give you the most amount of profit will be in one of these corners, not anywhere else.
Right.
That's it. Cool. That's 37.
I have no idea.
For 38?
Yeah.
Okay. You guys ready for 38?
Yeah.
All right, let's go back here. $38. If you have your book with you, great, but I don't require you to bring your books here, so that's fine. But if you were doing homework the other day, you should have seen a little picture next to 38. Did you see it?
Yeah.
Okay, it was just a little dude playing baseball. He was by home plate. But essentially, here's what the problem is saying. In baseball, the strike zone, yeah, is that the right one? Yeah, that's the right one. In baseball, the strike zone is a rectangle the width of a home plate that extends from the batter's knees to a point halfway between the shoulders as and the top as of the uniform pants. Blah, 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 blah. The width of home plate is 17 inches, meaning that home plate stretches from 0 inches to 17 inches. So your x dimension is going to be 17 inches long. So you know that x has to be greater than or equal to 0. You can't have a dimension less than 0. And it stretches for 17 inches, home plate. So x has to be less than or equal to
Wait, what is the x
17.
represent?
What's that?
What is the x represent?
The x represents the horizontal distance. So, if I'm remembering the book correctly, there's a guy. Okay. Here's a little baseball bat. Playing baseball, okay? And there's a home plate right here. What it's telling you is that like hit zone is right here. where this is, maybe I should make him taller, but whatever. This is the height of his knees. This is the height of his waist, top of pants. And this from here to here is 17 inches, the width of home plate. So what it's telling you is the x dimensions go from 0 to 17. So the x dimensions go from 0 to 17. And the y dimensions at the knee are 20 inches. So y has to be greater than or equal to 20. And between the shoulders and top of his pants is 42 inches. So this part right here, I guess that's not, let's call that shoulders. Is 42 inches. So y has to be greater than or equal to 20, but y has to be less than or equal to 42. It's a lot simpler once if you saw the picture. If you didn't use the picture, it's pretty confusing. And also, if you don't know enough about baseball, it's also pretty confusing. So I don't know anything about baseball, so for me, the picture was my victory. So we have those 4 inequalities. Do you want me to graph them on Desmos, or do you feel okay with graphing?
The graph looks really strange.
It's supposed to be square, right?
No, it just continues going.
Well, try it out.
So then you can zoom out and you never see it.
Isn't x is greater than or equal to 0 given?
X, a given?
No, is there a linear program
What about linear program?
that x has to be greater than or equal?
Yes.
We have to put an x is greater than.
In this case, yeah, because it's asking you to. And this is also a good rule of thumb whenever you're graphing. So you can find your points, just make x greater than or equal to 0, y greater than or equal to 0. That way you focus on always the first quadrant. So again, we can focus on the first quadrant, we can do this. Notice how my y is less than or equal to 42? Yeah, I need to zoom out a little bit. Because this y right here needs to be at least 42. And the x needs to be at least 20. So if I graph these 4 guys, x greater than or equal to 0. That makes it so it's all positive. The next one, x less than or equal to 17. So now it's saying, not only is it just the first quadrant, but it's between here and here for the first quadrant. The next piece, y is less than or equal to 42. So now it's cutting off that top right here. And then it's saying that y has to be greater than or equal to, what was it? 20. Okay. So my feasible region is right here. From 0 to 17, from 20 to, I wish it was taller, 42, here. That's my feasible region. 0, 20, 20, 17, oops, 17, 20. $17.42 and $0.42. So if you see it in your book, that's going to be the square. So that's the optimal area to hit it. Okay. Usually, for those of you that watch baseball or don't, yeah. The home runs usually happen right here, right? Kind of like that area. You have to swing on the bottom part. I'm assuming I don't watch baseball. Anybody here watch baseball? Yeah. You have to hit it on the bottom part, right? If you hit it on the top part right here, that ball's going to just mainly go that way. If you hit on the bottom, it's going to swing up. Or so I think. I don't watch baseball. That's 38. Number 40 was a challenge problem. Just for the sake of time, we won't graph 40. but I will show you how to do the inequalities. All right, 40. You and a friend are trying to guess the number of pennies in the jar. You both agree that the jar contains at least 500 pennies. You guess that there are X pennies, and your friend guesses that there are Y pennies. The actual number of pennies in the jar is 1,000. Write and graph a system of inequalities describing the values of X and Y for which you guess your guess is closer than your friend's guess of the actual number of pennies. So both of you agree that there are at least 500 pennies, right? So both you and your friend agree the number has to be at least 500. So X, your guess has to be greater than or equal to 500. Y, their guess has to be at least greater than or equal to 500. So your guess was X, your friend's was Y.
So would you X equals 1,000? Or no?
What can neither of your guesses go over?
1,000.
1,000, right, to be actually valid. So X has to be less than or equal to 1,000. And Y has to be less than or equal to 1,000. There's a C next to the problem, which means challenge. And usually I try to give you one per homework. I think the last couple homeworks I did it. But this one is a challenge. If you've ever like guessed a number between 100 between you and your friends?
Yeah.
Yeah, you have. So let's say, Ben, let's say I pick 50. What are you going to pick?
51.
Why?
Because I have the best chance.
You have the best chance of getting it, right? Because then you've cut me off completely at half. So if he chose the random, let's say he chose the number 58, and the number was 54, or 52 for that matter, 53 for that matter, 52, I would be closer, because I'm closer to 52, because I'm at 50. He's at 58. So he's lost a few of those points. But because he chose 51, any number that's higher than 51, he automatically wins. Any number that's below 50, I automatically win. So he's made his chances as best as he could. So if I chose the number 2, all he would have to do is pick 3. That's kind of that. So what that means is, it says write and graph system of inequalities describing the values of X and Y for which your guess is closer to your friend's guess. So let's say my friend picked 50. Mine would just be one larger than that. Just one larger. That's all it needs to be. You could have made it a slightly different equation, but just one larger.
Then you get Y by itself. Then you get Y by itself to graph.
Yeah, you can get Y by itself to graph, or with Desmos, it can actually do X by itself. Yes, sir.
Could you also do X is greater than or equal to Y plus or minus 1? Did you go where you get like lower?
Well, you could just, well, it's plus or minus 1, that'd be an extra inequality, but then you start playing with, this number would have to depend on that number, and it gets a little tricky.
Right. Because I was just thinking, like, if you chose 50, you could either choose 49 or 51. And then that way.
You could have done Y minus 1 if you really wanted to.
Okay.
Yeah, just not both,
Okay.
just one, because you only have that one choice.
Right. Okay.
All right, that's it for 40, then you just graph them and that'll be it. Did anybody have questions on 48, 49, 50, 51, or 52? Those were review questions. Yes? You did? No? Okay. All right. Yesterday we kind of rushed through linear inequality. Would you like to recover it? Yes or no?
Sure.
Yeah.
Sure? Okay. Let's pull it up. 2. When you get it, whenever you need to use it.
So I just gotta remember that I have homework pass.
You have an actual paper.
So much work. I
No,
have it.
false. It will not kill paper for your sake. All right. So this previous problem, if you remember from yesterday, we had clothing company has 100 yards of cloth and produces shirts and vests. Shirts require 10 units and have a profit of $5, while vests require 4 units and have a profit of $4. Also, disregard what's on the cycle sheet. Okay, it's going to change slightly because I'm going to send you an email with the problems. Don't go off the cycle sheet. We're just going to be moving everything one day up, so we're going to do linear programming project next time I see you. Not today. So shirts require 10, vests require 4. Shirts give you a profit of 5, vests give you a profit of 4. Solve what we did yesterday. So we only had one constraint. 10 yards for shirts plus 4 yards for vests has to be less than or equal to 100 yards, which is what we have total. Our profit function, $5 a shirt plus $4 vest, gives me my total profit. When we graph that one inequality, again, x and y have to be greater than or equal to 0. We get this, which is pretty simple because it's just at 3 points. 0, 0, which is stupid because if you're not selling anything, you're not making anything, you don't need to test it. So really you only have these 2 points. So when we have those 2 points, we can just check them really quick.
Wait, so what did you graph? Did you get for,
What did I graph?
what did you change the equality?
Oh, sure. So if I have, is it 10x plus 4y less than or equal to 100? Subtract 10x from both sides, so I have 4y is less than or equal to negative 10x plus 100. Divide everything by 4. Negative 10 fourths. You can simplify if you wanted to, it doesn't really matter. Alright, so 25 is the y-intercept right here. Keep it going down, 10 will be your x-intercept. And you can check. Once you check by putting it into your function, you'll figure out that selling only 25 vests and no shirts will give you the most amount of money. Compared to yesterday in terms of everything that we did, do you feel more comfortable at all?
Yeah.
A little bit?
Could we do it with like multiple other animals?
That's what's right here. So we rushed through it yesterday, so why don't you try it out by yourselves? I'll walk around if you have any questions. You want some light on? If you have questions, just call me over. Does this make more sense than yesterday? Yes. Yes, some problems yesterday. But we will have another practice problem.
Shirts is X, right?
Shirts is X, vests are Y. On Canvas, I'll put a resource sheet. Oh, I made a YouTube channel last night, midnight. So I'll be posting videos. That video will be on there. Subscribe. Make me money. No, I'm just kidding. No, I figured it'd be easier if I had a YouTube channel, somebody missed class, or just you didn't copy something down really quick, or you just wanted to hear me say something again. You can hear my own voice on YouTube. Okay, so we know this variable for shirts is what? Is X, right? So we have to have at least 3 shirts. So X has to be what? Has to be 3. Can it be more?
Yeah.
Yeah, so it can be 3 or more. So how would we write that as an inequality?
So 3 or less than or greater than.
X is greater than or equal to 3.
This.
I'm going to post a little sheet on Canvas, a little cheat sheet that we used to use probably in middle school. Greater than means this, less than means that, more than. Okay, so you've got that one.
Yeah.
And that's.
It's just y is greater than or equal
Oh, you need to do it.
I thought because I was like trying to add them.
Oh. Two questions.
I think I got points when you're submitting, so I think.
You flipped it. X has to be greater than or equal to 3 and y has to be greater than or equal to 2. Yes, ma'am. Graphic solution. Since it's asking you, obviously all the goals with linear equations is money. Which money can make, which one gives you the most amount of money. So you have to figure out how much you have to sell shirts, how much you have to sell invest in order to get the most amount of money. So most of you have pulled up these two inequalities. X has to be greater than or equal to 3. Y has to be greater than or equal to 10. So your new graph is going to look something like this. No. Not always trying to. Remember the first rounds that we did 37? It was rectangle? Yeah, we did a rectangle with baseball.
Yeah.
It just depends on how many constraints you have. Yeah, it depends on how many constraints you have and how you have them cutting. Yes?
What does the non-zero constraint do to the problem?
What does it do? It means you have to sell at least a little bit of something. So non-zero constraint. So if you remember before, we had that point 0, 0 here, right?
Yeah.
We had a point 0, 0. We had 10, 0 here, and we had 0, 25 here. It means we could have sold no shirts potentially, or no vests potentially. You can't call yourself a company shirts and vests if all you sell is shirts, because that gives you the most amount of money. Then you might as well just call yourself shirts. So what that's saying is non-zero constraint means you have to sell at least one item. You want to be called shirts and vests, you need to sell at least one shirt or at least one vest. Does that make sense?
Yeah.
Yes, sir.
So I was just wondering for the top constraint, 10x and 4y is less than or equal to 100. I was wondering, where is that like visible in the graph? That.
This right here. When we took this and we converted it, Ben asked this question. If we get y by itself, subtract 10x from both sides. So we'd have 4y and then divide everything by 4.
Right.
100 divided by 4 is 25. Where's your y-intercept right here? 25.
Is there a way to make the only enough feasible region if you're doing that?
Oh, that's the $1 million question. I've been working on it for about 9 hours now. Just working asking people. If you figure it out, please let me know.
Just look it up.
I've been looking it up. I called TI Inspire. They said it works. You used to be able to do it on the old TI Inspire. We could actually make the feasible region white.
Right. So that's one.
Yeah, it's just a work in progress. If somebody finds out, please let me know. I've tried Googling, YouTubing, everything.
Wait,
All right.
wait.
Yes, sir.
What's your YouTube channel?
I haven't fully updated it yet, but I'll let you know. I'll send out an email.
Okay.
I'll send out an email.
Right.
When I post this video and edit it,
Yeah.
I'll send it out. All right, so we have these 3 points. I think Matthew was talking about this point the other day. Why can't we have a decimal?
Because it's not a whole number.
But a whole number, you can't have half of a vest. You can't round this up. Which that?
If it's 0.6, do you round up?
No. That's 0.9 you can't round up. It's 0.99 you can't round up. Because what that 0.01 does, or the 0.11 that you round up, it means that you're using a little bit more than what you have. You only have 100 yards of cloth. If you round up, that means you're using up more than you have, and you don't have more than you have, so you have to round down always. So this will be 3 and 17.
Yep.
Yes, you can have a little bit over, left, like some scrap fabric, but not actual
Pocket.
So if you do this, substitute in your profit function, 3 and 17.5 would be the best one, but 17.5 again would round it to 17. So 17 times 4 plus 5 times 3 gives me 83, which gives me the most amount of money. So I should sell 3 shirts, and 17 vests. Makes a little more sense than yesterday? Hopefully it does. All right, you ready for a whole practice problem for yourselves?
Oh, yeah. Oh, wow.
Yes.
Great job.
All right. All right. Pinatas are made to sell at a craft fair. It takes 2 hours to make a mini pinata and 3 hours to make a regular pinata. The owner, good lot of me, of the craft booth will make a profit of $12 for every small pinata and $24 for every regular pinata. I have no more than 30 hours to make pinatas because I have a life. But I need to sell at least 12 pinatas. How many of each pinata should I make to maximize my profit? Anybody know how to add the, I don't know what it's called in English, I know what it's called in Russian. How to add, never mind. I like being accurate.
The accent?
Yeah.
What's it called in Russian?
Vietnamese knock. So, yeah, there you go. All right, have fun, try it out. Take about 5 minutes, work through it. If you've got a question on what something means, call me over. I'll turn on a little bit of light, just so some of you can see. Max, if you don't want to get another calculator for the matrices, I think you can use that one fairly well. The one that's
Okay.
it's just using the lists.
Okay. I'll probably get it.
Did I forget which class I talked to? The TI inspires. Did I already tell you which one you can use on test, which ones you can?
You sent us an email. The one with cast.
Mm-hmm.
Yeah, we got an email.
Oh, you got an email. Okay, I don't know if it went through because it told me I had an error.
I don't know.
Which one is the really?
I think it's
Yeah, but make it equal.
why.
There's, what about your profit function? So yeah, if you're trying to buy a calculator, the TI Inspire CX you can use on the ACT and SAT. The TI Inspire CX CAS you can use on the SAT, but not the ACT. Why? Because ACT does not allow computer algebra systems. That's what CAS stands for. Especially like I had a TI-89 in college, in high school and college, I can use it because you can do everything with that. You can literally solve equations, solve systems, just type it in, click solve, and it will solve it. It's a lot easier. You can do integrals, derivatives, whatever you wanted on the CAS systems. Yes?
I have the constraints.
Yep. That's it. So now you just have to write your profit function. So money. So, what time do we end today? 1:30? Cool. Mini pinata takes 2 hours. So I can have X. My marker's done. Mini pinata takes 2 hours. So mini pinata will be mini. X will be mini. It takes 2 hours. And it makes me $12. Why? Be regular pinata. So it's also going. Look at this. Regular pinatas, 3 hours. And I get $24. Hopefully that should make sense with all that data. So my inequalities, well, I have no more than 30 hours. So I know that all my mini pinatas that I spend time on, plus all my, what's it called? Plus my regular pinatas, cannot be more than 30. So I have to be less than or equal to 30. I also know that I have to make at least 12. So X plus Y has to be greater than or equal to 12 pinatas. Those are my 2 constraints. If I want money, the profit function will be $12 for a small pinata plus $24 for a large pinata. And I'll only do this when I'm all done graphing. Do a few more minutes, so we'll go ahead and graph those really quick. So if we go to Desmos, let me hit this light.
Let's use Desmos on the example.
What'd you say?
We'll have to use the TI Expire on the example.
You can use your iPad. Yeah, you can use your iPad. I wouldn't teach you something if you couldn't use it on the test. You know what I'm saying? Like if I had a no calculator portion of I want to see you do it by hand, yeah. But you should know how to do it by hand because we did do those. But linear programming, I won't make you because I'm not asking you to find intersects by hand. All right, Desmos, graphing calculator. X plus Y is greater than or equal to 12. Well, I just want Y by itself, so I'll have Y greater than, if I subtract X from both sides, I'll have negative X plus 12. And we'll zoom out in a second. And the other one, if I subtract 2X from both sides, I'll write it out. I would have 3Y is less than or equal to negative 2X plus 30. Divide everything by 3.
Yeah, how do you do it on the TI side? Are you just putting the parentheses?
Put in parentheses, negative 2 divided by 3. 30 divided by 3 is 10. So I took that in. So Y is less than or equal to negative 2/3 X plus 10. That doesn't show me something in a row, so I'm going to zoom out a little bit. Again, I only want the positives. I see that my only overlapping area is from here to here to here. Oh, that's weird. Looks like this. Let's see, zoom out. I don't know why it's not coming up, sorry. So it should look something like this.
Got it.
And then your 3 points will be here, 6, 6, 15, 0, and 12, 0. You would check those 3 points, figure out which one gives you the most amount of money in your profit function. I don't know why it's not popping up, but, oh, network error. You guys can back up. I'm going to connect this really quick so you can see. Okay. There we go. So you're just checking those 3 points in your function. So again, don't follow the cycle sheet. Just look out for an email from me. I'm going to send you a PDF file of like probably five problems to do for homework. Okay.